Having an AI just walking around your game can really help making things feel more alive. And it's actually not that complicated to create. So let's get into, we'll come back here, how to make this exact thing. These are all the objects we're going to need. So take a quick look at them, but we're going to make new ones just so that I can show you everything we do. So let's make a folder, new, and get started. The first thing we're going to do is adding a blueprint class and going with the character one. We need something with a movement component, and for that you need a character. So let's call this character moving. Really doesn't matter what you call it, but anyway. So then we add our mesh. You want to make sure that your character is facing in the same direction as the arrow, which probably is about 90 degrees turned. So that it's facing forward, and then that is everything we're going to do here for the moment. Next thing we're going to make is another blueprint class, but in this case we're going to look down here. If you don't see this, you probably don't have this expanded. You can just click on the little arrow there and you can get all classes. Type in AI controller, and that's the next thing we're going to make. So we're going to call this AI controller, AIC. It doesn't matter that you call it this, but do label it something clear and obvious. AI controller walker. And in this, we're not going to do anything yet, but we need to make that because we need to set this character to be using that AI controller. So select the character moving, don't select the mesh, don't select the arrow, don't select the capsule component, select the actor itself up here. Go over to the search tab and type once again AI. Auto possess AI place in the world. You can also make this place and spawn in the world. If you have something that spawns in characters, you're going to want that as well. Then the AI controller class is going to be the AIC we just made, AIC walker, and for the time being, that's everything we need here. Next up, we're going to go into artificial intelligence and make a behavior tree. We're going to call that BT walking, and we're going to make a blackboard as well. The blackboard is going to hold all the variables that are used inside of the behavior tree. So we're going to call that BB walking. And then when we open up this seems really intimidating. We're doing artificial intelligence. It's really not that bad. This is a behavior tree. It works much the same as a normal event graph would, whereas a normal event graph starts at begin play or whatever other event might be called through it and moves generally from the left to the right. A behavior tree is, well, more of a tree. It works from the top to the bottom, and it can make choices as to what to do at what points. Can you do most of this stuff in a normal event graph? Yes, you can, but this is much more effective. If we pull off this, we can add in a selector that is making a choice, a sequence that is a number of different actions after each other, or a simple parallel, which we're not going to get into right now. For the time being, we want to have a simple sequence. And from that sequence, we're going to drag off a waiting node. And that wait time, you can just pull in everything you want. Let's keep 5 seconds and random deviation, let's say 3.5 seconds. That means it's going to wait 5 seconds, 3.5 seconds more or less than that. So it's going to wait anywhere between, like, what is that, 1.5 and 8.5 seconds. Next up, we're going to go to making a new task. And as you can see, I already made an AI move to custom, but we're going to use the blueprint base for that. We're going to give it a name, BTT task random movement. And once we've opened that, we type in event AI execute. So every time the behavior tree executes this task, this event will fire. And from here, it's relatively simple. We get our control pawn, and when you drag off that, we're going to get the world location, the actor location. And then we get a vector, which is the exact coordinates where this actor exists in the world. Dragging off that, we will get a random navigable or reachable point. It really doesn't matter that much. Either will work for this case. And we will have to put in a radius. Now, You can just put in a radius like, I don't know, 500, and now all your AIs will walk around within 500 units each time they move. But wouldn't it be much more interesting to be able to tell every single AI specifically how far they're allowed to move? So in order to do that, we're going to get value as float, and that will give us a key to a float. So the float is going to go into there, and we're going to promote the key to a variable. We're going to call that range key and set it to public. Now, in order to get this value, we're going to go back to our character moving. That is this one, the one we just made. And inside the event graph, we're going to delete these two because we don't need those. And we're going to make a variable. We're going to call it range. And the variable is going to be a float. After we compile it, we can set its default value if we want to, which you probably should. Let's set that at 500. And then when we drag that in, holding Control to get a reference to it, we can set value as float. And you will see that that does not return what we needed. That's because context sensitive is turned on and it doesn't know that we want to do something with Blackboard AI. So if you turn that off, you will see set value as float. And we will plug that into the begin play, and we will plug the range into the float value. Now, we need a Blackboard reference and we need a name. Let's do the name first. That's as easy as make a literal name. And this is a way that without making a variable, you can put in a specific value into a specific node. So let's call this range. And then we need to get a reference to our Blackboard. So that is as easy as, you guessed it, get Blackboard. And you just plug that into this. And now when we go back here, we can set it up so that we can feed that information into this event. Dragging up this execute pin, we can go move to location or actor. The reason we use this one and not a simple move to location, the normal one, is that you can see this only has just one out pin, and this one has a couple of different ones, one of which is on move finished. Because we don't want this to happen every tick, only walk somewhere, wait a while, then walk somewhere else, but the waiting only has to start once you've finished the movement. So this is a very good node to do that. And it's as easy as just plugging in the random location we just created and get the owner controller into the controller pin for this movement. Then we just pull off on move finished and we say finish execute, and we do a success. Just to be sure, we will also make a finish execute when success is false, which we hook into on request failed. Back in the behavior tree, this is where the magic happens, right? So we can drag up this sequence and just type BTT task random movement, the one we just made. And you will see that because we set the range key as a public variable, we now have a drop-down menu where we can actually say what variable corresponds to that. So if we click over to the Blackboard here, we can make a new key. That's kind of like making a new variable, but for the Blackboard. The Blackboard needs keys in order to access information. So we can make a new key, that's a float, and we call it range. It is very important that this name matches the name that you put into this node, because it's going to look for that name and then set the value of that specific named key to this input. Now that we've made that, we can go back to the range key here, input range. Before the AI can actually start moving around, you will need to add a nav mesh bound. So here in the place actors, you go nav mesh bounds volume, you drag that into your map, and then here in the details panel, you can get its settings. So you make this as large as it needs to be. Don't make it too large because it does end up being quite resource intensive if you make it too large without it needing to be all that big. But if you just cover the entire play area in a nav mesh, then the AI will actually know how and where to move. Now that we've done all that, we've made a behavior tree, we've put the AI controller into the character, we need to do one last thing, and that is inside of the AI controller itself, we need to go to begin play and say run behavior tree, because it needs to know which behavior tree it needs to run. So we make this one, and if we now start the game, you will see that our character is randomly moving every 1.5 to 8.5 seconds in a certain range. If we then, back in its blueprint, set this range variable that we made to being public and compile it, now when we're in the map, you will see the range it can walk. So I can set this one to a range of 100 and then drag in another one and give it a range of 1,000. So this one will be able to walk much further than this one. It's kind of difficult to show that because obviously, yeah, it's random. But this one will only ever walk very short distances. 100 is definitely too short. Whereas this one will walk very, very far if it gets the opportunity, as you can see. So just making some wandering AIs, either as enemies or just as citizens in like a city you're making. This can go a long way into making your world feel more alive. Last time we made these randomly wandering AI characters. If you could walk for me, that would be freaking great. You walk around. There we go. You're trying to walk around a bit. That's what we made last time. Today, we're going to get started on the first little bit of what you see here. And that is an AI that'll shoot at me when it sees me. As you can see, there's lots of room for improvement. We won't get to the actual shooting today either. We will just be talking about the bit where it perceives you, because that in and of itself is complicated enough. So what we have here is the things that we made last time. We made our character, our movement task, our behavior tree, our blackboard, and our AI controller. We're going to be opening up the AI controller, which is over here. And to the AI controller, we're going to add an AI perception. So we have AI perception over here. And we're going to add perception, sense config, add an array element, and add in sight. You can also set a dominant sense. I think this only comes into play if you have multiple senses, but you know, you might as well just set it to sight so that nothing weird happens. And then it's very important in your player character, which in this case will be our first person character over here. When you open that up, you also need an AI perception stimuli source, which you can just get by AI perception stimuli source, as you would expect. And inside that, we're going to go to register source as, and then AI sense sight. You also want to enable auto register as source, so that you don't have to like trigger an event or anything. Then back inside the AI controller, there is a lot of things under these submenus that you can change, like the side radius, the loose side radius. The side radius is when the AI starts perceiving you, but if it starts perceiving you and you take a step back, it won't lose that perception of you until you reach the loose side radius. So if you want them to be not able to see you, but once he sees you, it'd be very difficult to get out of his range. You would set this, for instance, like 150. Very, very small. You have to be right up against him to actually have him see you. But then, for instance, set this to 5,000 so that you have to run away very, very, very far in order to lose it. That being said, the usual 3,000 and 3,500 kind of work well enough. Peripheral vision is exactly what you assume it to be. If you set it to 180, its peripheral vision is going to be 180 degrees. If you set it to 90, it's going to be more or less what you would normally expect. Having the perception selected, you will have to right click here and then add event for AI perception. Event dispatchers, and you're going to go to the bottom one. Add on target perception updated. So this means that when it goes from seeing something to not seeing something, or from not seeing something to seeing something, this event will get triggered. We have an actor and we have a stimulus. So we right click on stimulus and we split that structure pin, because the only thing we really care about at this point in time is whether or not a stimulus was successfully sent. This will allow us to know whether or not the character has just entered or just exited the sensing range. So we're also going to want to check whether or not it's actually our player character that we're working with here. So what we're going to do is we're going to drag off the actor. We're going to cast to whatever your player character is. In this case, that's BP first person character. And we don't really do anything with this character pin at all. It's just to check whether or not it's that specific character. So after that, we're going to set a value as a bool. And you might see that the thing you need isn't here. Turn off context sensitive, and now we can set blackboard value as bool. We're going to have to get the blackboard, obviously, for that. We're going to have to make literal name. And we can call this something like can see player. And we hook that up into there. This is important that it's the exact name that you're going to give your blackboard key in a second. And then the bool value is going to be equal to stimulus successfully sensed or not. And that's everything we need to do here. So now we can move back to our behavior tree, which, if you remember correctly, looked like this. It's not much of a behavior tree. Nothing much is getting decided here. It's literally just doing one thing, then the other, then one thing, then the other. And as we discussed last time, it's mostly something we could have done within normal blueprints. This is where things get interesting, because now after the root, we're going to add a selector. A selector will first try to do what's on the left-hand side. And if that does not work, it will go to the right side. Why would it ever not be able to apply this sequence? That's because we're going to add a decorator to it in a second. First, we're going to go here, new key, bool. And as I said, it's very, very important that we get this exact text, capitalization and all, as the name for our new bool key. So now that we have that key made, we can go to add decorator, blackboard. Once we have made that blackboard, we can select it and then say blackboard key, can see player is not set. So now the random movement will only ever happen when the AI cannot actually see our player. But we also need to give it something else to do if it doesn't do this. So we're going to drag off this again. We're going to make another sequence. And this one we're going to just copy over this waiting node. We're going to start with waiting. The wait time for this one is going to be a little shorter. I'm going to say 1 second with a random deviation of 0.3. And just to be sure that this works as intended, we can copy over this blackboard condition and select our sequence here, paste the blackboard condition, and then set this to is set. So now, every time this tree runs, it'll go to the left, check whether or not can see player is set. If it's not set, it'll do this sequence. If it is set, it'll go back to the selector and pick the next one down the tree. Then can see player is set, should be true. Then it'll wait and do whatever action you put after it in the sequence. You probably also should go over to your decorators and observer aborts self, lower priority, or both. I would advise doing both here. So what that means is if you're in the middle of doing one of these sequences, let's do both. If you're in the middle of doing one of these sequences and your player changes from being inside to not being inside, it doesn't finish the waiting tasks here. It just immediately jumps back up to the root and runs the behavior tree again, so that you never get stuck with an enemy AI that's just doing the wait node thing before moving on to doing more AI things. It gets a lot more snappy. And then once you get into the game, the moment the AI senses you, it will start doing whatever task you set it to do. In this case, that'll be shooting me, but that could also be chasing you, right? You could say, if, for instance, you see me, you start moving towards my location, and it's not that difficult to do that. As a matter of fact, it's actually easier than the shooting thing. So you can really put any task you want after this. This is just about how you can sense the player. It's relatively easy, but it's a very, very powerful tool. Last time we talked about AI perception, making an AI able to see us. Today we're going to complete that by making the thing that you're seeing right now. An AI that'll actually look at us, but more so than that, it'll shoot at us. But it'll shoot at not where we are, but at where we're going to be. So to just immediately get started, open up your enemy character and add a new event. We're going to add an event tick. This will run every game tick. first and foremost, before we do anything else, we're going to add a branch by holding down B and just clicking. We add a branch because we need to check whether or not we're actually inside of the enemy, because it shouldn't always be rotating towards us, only when we're inside its sight radius. So to do that, we get a value as bool, and that'll return nothing. But if you turn off context sensitive, you can then get it from the blackboard. And we need to put in two things, a blackboard and a key name. So we can get the blackboard, if I spell it correctly, and that'll go into the top slot here. And then we can make a literal name, and that'll go into the key name. And what do we put into the literal name? Well, last time we made a key, can see player, in our behavior tree. So just go over and copy that, because it's very important that it's the exact same text, and put that into the make literal name. And then that goes into the condition of the branch. So now, if that's false, we do nothing. But if it's true, we set the actor rotation. And here you can do it very easily by just using find look at rotation. We're going to do something a little bit more fancy, because we're going to drag over the delta seconds and we're going to type our interp to constants, and just put this to the side a little bit. Here we need a current rotation, a target rotation, and an interpretation speed. So this interpretation speed, it really depends on the scale of all your characters and what your game is like. I usually find that somewhere between 75 and 100 works fairly well. So let's go with an 80 here. The current rotation is very easy as well, because we can just get the actor rotation. Again, if I can type properly. We get the actor rotation and put it into current. Now, the target location is slightly more complicated, but not really, because here we find look at rotation. We plug that into here, but now we have two more things to fill in, right? Well, no worries, this also is very easy, because we can get the actor location, and that is all we need to do to plug into the start here. If we then copy over the actor location node again, we can also plug something into here. If we don't do it, it'll just use itself as a reference, but for the target, of course, we want a player character. So we can get the player character. If you wanted to shoot at another like AI enemy, you're going to need to get a reference to that. For the time being, that's not relevant, but do know that you can use this for more than just the player character. It's just a little bit more of a hassle. So then we put that into the target, and putting that into the new rotation. That's literally everything there is to it. If we now go into the game over here and we get into the sight of one of these characters, it'll start turning towards us, but at a speed where we can... I also had a cast fail for some reason. At a speed where we can actually outrun the rotation, so we can free ourselves of the sight, which is, for gameplay purposes, just a very good thing to have, right? So that's the easy part. Now we're going to get into the enemy having to shoot us, and there's two parts to that: the spawning of the bullet and the prediction of where our player character is going to be. So let's start with the bullet, right? Because we do need a bullet. So let's just make one. We can make an actor. We can call it enemy bullet. And if we open that one up and have it on the right monitor, we can let's add a static mesh here, because we need to be able to see the bullet to dodge it. So let's make that a sphere. Let's make that a sphere correctly spelled. It's a little bit big by default here, so I'm going to make it a bit smaller. And we're also going to add a projectile, we don't need to say add there, projectile movement component. And we're going to set its initial speed to 1. You can also set the projectile gravity scale to whatever you need it to be, either 0, 0.1, something like that. Depending on whether or not you want it to have heavy gravity or no gravity or a little gravity. I leave that up to you. It really doesn't impact the rest of this tutorial whatsoever. So back into the actual character, we're going to make a custom event, and we're going to call it shoot player, because that's what we're going to do. We're going to shoot the player. And in order to do that, we're going to need to spawn actor from class. And the class that we're going to spawn from, take a guess, is going to be the enemy bullet. Collision handling override, you can say always spawn, ignore collision, because otherwise maybe sometimes it won't spawn because it thinks it's overlapping with the enemy itself. So just make sure that it always spawn. Now, dragging off this pin, we can get the projectile movement component. And from that, we're going to get its velocity. As you might have been able to see already, I've made a bullet speed variable here. So we're going to drag that one in as well because we're going to use that by multiplying the vector by the bullet speed. The vector is a very small number here because we set the initial velocity to 1. And the reason we did that is so that we have it traveling in a direction, even if it's very, very slowly. Then the actual speed is going to be set by the character of the enemy here, because the enemy actually needs to know how fast the bullet is traveling. And if we set that inside the bullet itself, the enemy is not going to know that. So that's why we do it this way. And then after we've done that, we're going to get a set velocity. And we're going to plug the answer here into the set velocity node so that it's actually moving fast enough to be a proper bullet. That's the spawning of the bullet, but it still doesn't have a direction. And we're going to get into the transform now. So we're going to split the structure pin for the spawn transform. The scale is going to get actor 3D scale, so that it's always going to match whatever scale our actor is at. The transform location is going to be equal to this shooting direction arrow, which you can just make by saying add arrow and then place it wherever you want to shoot it from. If it needs to shoot from like above its head, you can put it here. If it needs to shoot from its feet, you can put it here. Generally, I would say somewhere around the neck or chest is probably a good place to shoot from. So I've got my shooting direction arrow over here, and we're going to use that get world location to use as the source from where we shoot from. Now the only thing that's left is the rotation, and this is the interesting bit. We're going to copy this shooting direction arrow over here, and we're also going to actually copy over the world location, because that world location is going to go into a find look at rotation as well. We can just hook up this into there, because this is going to be the eventual rotation we're going to be using. And then we're going to do a little bit of interesting math. Don't worry, I'll take you through it, because we're going to start by getting the player character. But we can't just get its world location and put it into here, because then we'll be shooting at where the player is at the moment of the shot, instead of where it's going to be on the moment of impact. So we need to do a little bit of prediction here. We're still going to get the world location of the capture component, not the mesh. It doesn't really matter that much, but let's go with the capture component. And we're going to add a little bit to that. So we're going to add, let's say 80. The reason we do that is because otherwise it's going to aim towards the center point of the capsule component rather than about like eye height. And then we're going to do an addition. But what are we going to add to it, you might ask? And this is where things get very, very interesting. Because we type a get distance to, the target is going to be self, other actor is going to be the player character. That distance is then going to get divided by our bullet speed, because this way we know how far the actor is away, we know how fast the bullet is traveling, so we then know how long it'll take the bullet to get to the actor. But we don't know how the actor is moving yet, so let's also get that, because that's very easy. We can just drag up the player character and get a velocity. If we scroll down all the way down, we get a get velocity, and from the get velocity, we just multiply that by the amount of time that'll take the bullet to reach the player. If we add that to the current player location, and we put that into the find look at rotation, we've done our predictive movement. If you find it too easy to dodge some of these bullets, because it's very easy to dodge them, since when they spawn, if you stop moving, they will just move to where you were going to be if you kept moving at that pace. So to make it a little bit more difficult on your players, you can multiply this by, I don't know, like 2 or 3, so that it'll shoot at where it expects you to be halfway there. Now the only thing we still have to do is add that back into our behavior tree, because this is what we made last time. We made something that would wait and then do an action. That action is going to be made right now. So we make a new action based on the base blueprint, and we're going to call that, well, let's also call it shoot player, why not? And as always, we're going to start that by an event executes AI. With the control pawn, we're going to cast to our character moving, or whatever the name of your enemy is, and we're going to trigger the shoot player event. After that, we're just going to finish execute, tell the game that it was a success to execute this, and then back in the behavior tree, we just add the shoot player task, and that'll be that. We're running into an interesting issue here, and that is that the bullet is actually blocking the sides of the AI. So that is something that I had not taken into consideration up until now. So let's open the enemy bullet again, go into the static mesh, and go into its collision. And for now, just set it to no collision. You can also set it to overlap. Let's set it to overlap, because if you're going to use this as a bullet, it'll damage on overlap, so just set it to overlap all. That's what that's all like, and until the next time, that is all I have for you as far as shooting AI goes. So we'll get into some more fun stuff with AI at some point in the future, I'm sure. For now, you have a fully functional shooting AI.